Welcome back. So in the last video I talked you about what is meant by projectile motion or what is meant by parabolic motion by giving you a simple example as to how parabolic motion can be explained. So in this motion, as I told you, I will explain about the general equations of motion or the general derivations of motion that is relevant, very important to the understanding of the parabolic motion. Alright, so I'll take a simple example I have been using so far. So an object moving in a horizontal plane, like this, and I will take the object here. There's some mass, and you don't need a mass actually. And I'll take the velocity v and the angle between the velocity and the horizontal as θ. So this is θ. So I take the object to be moving to a height h within time t and to a displacement of r within the same time t. Alright. So the object moves from here to here and the height achieved by the object will be h. So this is h. And this will be r. So here is time t equals 0. Here time t equals t. Here. And I'll take this position as A and this position as B, A and B. So consider motion from A to B. I can pull the general equations of linear motion S equals ut plus half at square. From A to B, I can write S equals ut plus half at square in the upper direction. So I can write the velocity here is v sin theta and the displacement is h. So h is equal to v sin theta times t plus half times minus gt square, that is minus half gt square. Alright, and this equals ut plus half at square in this direction, in the horizontal direction. Alright, so s will be r, the horizontal displacement will be r, and the initial velocity will be v cos theta, and the time t, you don't know, you have taken an arbitrary position and you have taken an arbitrary time. Alright, r equals v cos theta times t. Now you know that r equals v cos theta times t and h equals v sin theta times t minus half gt square. Now I will not derive the equation that I derived in the second video of the series of videos on projectile motion. So if you are not watched that video, I invite you to watch that video and come back here so that it will be easy for you. So this is the general equation, general motion that we will be using. H equals v sin theta t minus half gt square and r equals v cos theta times t. So that's the general equation of motion. So what happens if the object goes from A to B, if B is the same position on the horizontal plane as A? So that was the first position that I used in the first video. So that I will use that position to obtain another equation that will be easy for you when you are solving the problems in projectile motion. So I will consider that object A will be on the B will be on the same plane as A, like this. So the object is here. It has some velocity v and the angle is theta. So this is A. This is A at time t equals 0, and I'll take a position B here at time t equals t. So as I mentioned in the last video, the object moves in a parabolic path. So the parabolic path will be like this. Alright, so I will call now, if I take the vertical velocity of this object, it will be v sine theta, and as I mentioned in the other series of videos on mechanics, the vertical velocity will be maximum at the point of projection and at the point of contact with the surface, horizontal surface again. So the velocity of the object at A is v sine theta, and it will be the same at B, v sine theta, and at B it will change the direction. At A v sine theta will be the upward direction, and at B it will be v sine theta in the downward direction. But the object has the maximum velocity, however, at A. So at A and B it will be the same. If you consider the motion from A to B, the object will move to a certain height. So that's called the maximum height of the object in of an object moving under gravity. So the object will go to a maximum height and come back to B. So there will be some maximum height at which the object has zero velocity. So I will take that point as C here. So this is zero velocity, and the height I will take it as h. And the distance between A and B as r. Distance between A and B as r. So if I put the horizontal equations of motion, the linear equations of motion, I have already found that h equals v sine theta t minus half gt squared, so I don't need to repeat that. And you know that if h is 0, from A to B h is 0, you can find t. So I will use this coordinate to find h first. So to find h, you don't know the time t. Say if the time t is not given in this question, how to find h? So the only thing is that considering the vertical motion of the object, you can find h by putting v squared equals u squared plus 2as. So from the considering the motion from A to B, I will put v squared equals u squared plus 2as in the upper direction. Sorry, from A to C, right? A to C. A to C, because I won't find h. If I put from A to B, it will be very difficult because you have to find two velocities. From A to C, I'll put v squared equals u squared plus 2as. So at C, the vertical velocity is 0. The vertical velocity is 0 at C. So v equals 0. V is the final velocity. U is the initial velocity. Initial velocity is equal to v sine theta, because you know that the velocity of the object is v here, and the angle between the velocity and the horizontal is theta. So the initial vertical velocity is v sine theta. So u equals v sine theta and v equals 0, and the object is moving under gravity, so the acceleration will be downward. If I putting it in the upward direction, it will be minus g, and s will be h. So h will be the factor that I will need to find out. So I will put it. I will substitute the values here. 0 squared is 0. U squared is v sine theta squared, that is v squared sine squared theta. So plus 2 times minus g is minus 2g times s is h. So this is minus 2gh. So you can find h equals v square sine square theta divided by 2g. So this is a very important derivation. H equals v squared sine square theta. Sometimes in the problems you may have found out, you are given some angle theta, you are given v, you have to find it. So in some problems there will be a variation that some two objects are being projected on the same plane at the same time and at the same position, but they have different velocities and different angles of projection. So you will have to find the maximum height it will achieve. So that kind of problem you can easily substitute the value in this derivation and find the value of h. Similarly, you will sometimes be given the value of h and v, and you have to find theta. So like that, you can change the value of v and theta and find h. So this will be a very important derivation. Now what actually happens is that from A to B the horizontal displacement will be 0. Now I put from A to C to find H. So if I put from A to B, you know that the vertical displacement of the object will be 0. So if I put S equals ut plus half at square, the vertical displacement is 0. So u equals v sine theta, and I will take the time as t. So a is equal to minus g, so half times a times t squared is minus gt squared. So I can find half gt squared is equal to v sine theta times t. So t is not equal to 0, t is not equal to 0, t is equal to 0 means that the object is still at the position A. Now I am considering the object's motion from A to B, so the final time t should be the object's time at B. So time t is not equal to 0, so you can cancel one t, so t will be cancelled out and the final t will be t equals, this is cancelled out, so you can cross multiply from here, and g downwards. So 2 times v sine theta by g. So this is also very important derivation, t equals 2 times v times sine theta by g. So when I was explaining the concept of an object under gravity, I explained that the time taken for an object to go from the initial position to the maximum height excuse me, will be equal to the time that the object comes down from the maximum height to the initial position. So if I take an object going from position A upwards to the maximum height and reaching A again, so the time will be 2 times the sign that will be going, 2 times the sign that will be taken for an object to move from A to the maximum height. So if the total time taken is t equals 2v sine theta divided by g, so the time taken for the object to move from A to C, which is half times, which is half the height achieved, half the time taken, will be t equals v sine theta by g. So the time taken for an object to reach the maximum height, if an object is projected at an angle theta to the horizontal and velocity v, will be v sine theta by g at the maximum height, and will be 2 times v times sine theta divided by g for the whole motion. So this is also very important concept. Now if I put s equals ut plus half it squared from A to B in the horizontal direction, what will happen? From A to B, s equals ut plus half it squared in the horizontal direction. So let me tell you now, you know that this is s equals r because I have taken the vertical displacement here as, the horizontal displacement as r. So this is r equals, the velocity in this direction will be v cos theta times t you know already by now that t is equal to 2 times v times sine theta by g, so that I will directly substitute here 2 times v sine theta by g, and the acceleration of the object will be 0 because the object's motion will be perpendicular to the gravitational acceleration. So a is equal to 0, so half times at squared is equal to 0. So r is equal to v times cos theta times 2 times v times sine theta divided by g. So you know that you can, now I can take this out first, I'll tell you what happens here. So v times v times v is v square. I'll take g out as well here, g, and I'll put here bracket, and this is the remaining part is 2 times sine theta times cos theta. So 2 times sine theta times cos theta is actually sine 2 theta. So that will be as a new part if you are not well versed with math sums. So if I am not well versed with some math principles, I invite you to watch my trigonometric videos as well and come back. So actually 2 times sine theta times cos theta is sine 2 theta. So actually you don't need to be confused if you are not well versed in trigonometry. You can easily calculate theta and then find sine theta and cos theta. But actually what happens is 2 times sine theta times cos theta is sine 2 theta. So R is equal to V squared sine 2 theta by G. So R is equal to V squared sine 2 theta by G. So sine 2 theta is actually 2 times the angle we are taking. Now if you take the angle as 30 degrees and a velocity V, so R will be equal to V squared sine, not 30, sine 60 by G. Sine 2 theta means we are not multiplying the sine value by 2, you are multiplying the angle by 2 and then taking the sine value. So if you are, as I mentioned, if you are projecting an object at a velocity V, and if the inclination between the velocity and horizontal is 30 degrees, so R is equal to V squared sine 2 times 30 sine 60 divided by G, V squared sine 60 divided by G. So I have derived 3 important equations in this video. So I'll summarize that. If an object moves in a horizontal direction, moves so I'll take a horizontal path like this. An object moves with velocity V at an angle theta inclined to the horizontal, and it moves in a path like that. So I'll take this position as A at time t equals 0 and B at time t equals t, and Z at the maximum height sometime t equals t dash or something. You don't need actually. T equals 0, and at B t equals t, and at C the velocity of the object, the vertical velocity of the object will be 0. I will take the maximum height, and maximum height is at C, so the maximum height I will take it as h, and the displacement of the object as r from A to B. So this is h, this is h. From A to B I will take the horizontal displacement as r. Now, first of all, before summarizing this video, I have to tell you what is meant by R. R is actually called the range. Range is, now if you take some value, say some 5 values, 5, 10, 15, 20 and 25, the range between those values will be 25 minus 5. That is the maximum value of maximum if you are taking in some alphabetical, in ascending or descending order. You take 5, 10, 15, 20 and 25 in the ascending order, or 25, 20, 15, 10 and 5 in the descending order, and then you take the value of the range. Range is the maximum value minus the minimum value. So if you arrange that sum in the ascending order or descending order, the range is the same. So range will be 20 minus 5, that will 25 minus 5, that will be equal to 20. So what is meant by range is the displacement of the object, the distance between the maximum displacement and the minimum displacement. So the minimum displacement of the object will be 0 because we are taking 0 as the minimum displacement. We are taking time equals t equals 0, vertical height as 0, horizontal displacement as 0 at A, or time t equals 0. So the minimum height, so minimum displacement will be 0, so the maximum displacement will be B. So the range is from A to B is R, is the distance between A and B. Alright, so A and B is called the range here. That's why I choose R here, and because this is height I choose H to simplify. Alright, so if an object moves from A to B uh, under velocity v at an angle of theta, now you know that h equals, I'll find t first, I'll do t first, t equals 2 times the velocity used here times sine the angle between the velocity and the horizontal theta divided by g. Now I am not telling that not to memorize this, you just memorize this concept. You just memorize that the velocity here is v and the angle is theta and the height achieved is h, time taken is t and the range is r. Now sometimes the angle might be not theta, this will be sometimes in some problems the angle will be the angle between the velocity. Now they will sometimes give the angle between the velocity and the horizontal direction. So theta will be actually this one. This is the horizontal direction. This is the horizontal direction. Theta will be the angle between this one here. Alright, simply here. So the angle between the velocity and the horizontal direction will be theta. So do not memorize this, just understand what's happening here. So t equals 2 times the velocity of the so that's why I'm not saying t equals 2 times v times sine theta by g. So what actually happens is the time taken for an object to move from A to B, so that's at the same position, or so that the total displacement or vertical displacement of the object is 0. If an object moves in such a way, the total time taken for an object to move in such a path is 2 times the velocity of the object times sine angle between the velocity and the horizontal direction divided by g, and h will be velocity squared sine squared the angle between the velocity and the horizontal axis theta divided by 2g, and r, which is the range of the function, r equals v squared, that the velocity square, sine 2 times the angle between the velocity and the vertical, 2 theta divided by g. So t equals 2 times v times sine theta by g, h equals v squared sine squared theta by 2g, and r equals v squared sine 2 theta by g. So those are very important derivations in projectile motion. So in the next videos I will discuss about some examples of using these equations. So in this video I talked about actually the 3 important derivations on projectile motion. So thanks for watching this video, and see you in the next video with some examples on projectile motion.